Hello, we are going to discuss section P3. We'll talk about polynomials and special products, only the multiplying part. So basically, there's several sections in this class where we're going to look at some prerequisites and things that you probably already know. As we get started, just a quick reminder that this entire class, y'all can do it at whatever pace y'all need to go. However, you must take tests as scheduled, the week that they're scheduled, or sooner. I don't have any problem with opening up a test for you if you want to take a test beforehand. However, the final exam must be taken during the final week of this course, and that is a non-negotiable. But as you're moving through, all assignments are going to be done. I'm going to allow you to work on assignments. I'll never close them. So you can always improve your grade in the class for assignments. However, tests, they need to be taken, as I said before, at least by the day they are scheduled. Do not be late. It's your best interest to make sure your homework is done up till that, because you'll have a better understanding of what's going to be on the test. So today we're going to start off with prerequisites, polynomials, and special products. We're going to talk about multiplying polynomials. So here we go. What is a polynomial? One of the most common types of algebraic expressions is the polynomial. Some examples of polynomials include 2x plus 5 is a polynomial, 3x to the fourth minus 7x squared plus 2x plus 4 is a long polynomial, and 5x squared y squared minus xy plus 3 is also a polynomial. The first two polynomials are only in terms of x. There's only one variable in the first two polynomials I listed above, and that particular variable is just the x. The third polynomial is a polynomial in x and y. So that particular polynomial has, in fact, two variables within it. In terms of a polynomial in x, we have the form ax to the k power. We have ax to the k power. A is my coefficient. And k is the degree of the term. If a polynomial only has one term, it's called a monomial. Of course, mono meaning one. If it has two terms, it's called a binomial. Just like a bicycle has two wheels, a binomial has two terms. And a trinomial, just like a tricycle, has in fact three terms. And when we write a polynomial, we want to write them in what's called standard form. So in standard form, we have descending powers of x. So we look at the power on the x term, and that power needs to decrease. And if that's done, we are in standard form. And I have skipped some slides here. So let me go back, because there's another one down here. Sorry about that. So the polynomial 2x cubed minus 5x squared plus 1. That particular polynomial has three terms, 2x cubed minus 5x squared and 1. The coefficients on that are 2, -5, 0, and 1. So why do we say the 0? Well, if you look closely at that polynomial and the way they expanded it, they actually included that 0x term. So if we just had 2x cubed minus 5x squared plus 1, you'll notice that there's a term possibly missing there. I have a third degree term. I have a second degree term. I don't have a first degree term. I don't have that x term. And then, of course, I have my constant. So the definition of a polynomial in x is given right there. It's very long. It's arduous there. But what they're saying there is a sub n or whatever, those are just the coefficients for each particular term. And they're just indicating that they're different numbers for each one. The degree starts at n. So n is going to be the highest degree of the polynomial. And if you write it in standard form, you start with the highest degree term, and then n minus 1, and then n minus 2, n minus 3, and so on until you get to the very last term where you have x to the first power, and then of course there's an x to the 0 power. All right, now remember to scroll down on these pages. That'll get us going better. All right, sorry about that, guys. So a polynomial that has all 0 coefficients is called a 0 polynomial, and it's just simply the number 0. So obviously, if we have nothing but 0, you won't see any x to the 4th, the 3rd, or whatever, because the coefficient in front of all of those is in fact 0. The number 0 does not have a degree. If a polynomial has more than one variable, the term of a degree is the sum of the exponents in the variables in the term. The degree of a polynomial is the highest degree of its terms. For instance, the degree of the polynomial. Okay, so this is a real ugly polynomial. It's a polynomial in x and y. We have negative x cubed y to the 6th. So that's one term. We have 4xy, that's another term. And then we have x to the 7th, y to the 4th. Now, as you look at those, to determine the degree, you want to look at the highest sum. So in the first term, it has a 3 and a 6. So this right here is a 9th degree term because 3 plus 6 is 9. 4xy. Now, folks, you don't see an exponent there, but there is one there. The x has an exponent of 1 on it, and the y also has an exponent of 1 on it. So the sum of those exponents is 2. So that second term is actually 2nd degree. And then the third term, x to the 7th, y to the 4th, 7 plus 4 is 11. So that last term is 11th degree. So because 11 is the higher of the 3, then this would be an 11th degree polynomial. Even though it's the last term, it is the highest degree. The leading coefficient of a polynomial is the coefficient of the highest degree. So again, back on this polynomial, because this term right here is the highest degree, if we want to talk about the coefficient or the leading term or the leading coefficient, we have to talk about what is the coefficient, what is the number in front of x to the 7th, y to the 4th. And in fact, in this case, it is simply a -1. So the leading coefficient for this particular problem is -1. Expressions that are not polynomials when a variable is underneath a radical or when a polynomial expression is at the denominator of a term. So if I had something that looked like the square root of x, that's not a monomial, okay? Or if I had 3 over x, that's not a monomial. So we cannot divide by a variable. You also cannot have a variable inside a radical for it to be considered a term or a monomial. So because those aren't monomials, it cannot be part of a polynomial. So how do we multiply polynomials? Hopefully this is review to you. If I had 3x minus 2, which is a binomial, there's 2 terms there, and I wanted to multiply it by 5x plus 7. So I've got a binomial times a binomial. To do that, and it's written out right here, I have 3x minus 2 times 5x minus 7. What we're actually going to do is we're going to take that 3x and multiply it by both the 5x and the 7. And you can see that that's represented right here. I'm going to take that 3x and multiply it by the 5x plus 7. And then I'm going to take this minus 2 and multiply it by the 5x and the 7. So I've got the -2 multiplied by 5x plus 7. Now I'm going to tell you, folks, as I'm working problems later on in this class, you probably will not see me write it down like that. Okay, we're going to talk about, it's talked about right down below, simply FOILing. So if I had 3x minus 2 times 5x plus 7, I'm going to go directly to this step right here. Okay, So as I look at 3x, let me rewrite this. 3x minus 2 times 5x plus 7. So if I can remember the word FOIL, F stands for first. So what is the first number times the first number? 3x times 5x. 3x times 5x is 15x squared. Now I'm going to add to that outside times outside, or the outer terms. The outer terms would be the 3x and the 7. Those are the terms that are furthest away from each other. That's why they're called outer. So 3x times 7 is 21x plus. I'm now going to do I for enter. What are the terms on the inside? The inside of this polynomial would be a -2 and a 5x. -2 times 5x is -10x. And then L for last, FOIL, F-O-I-L, last times last. We're talking about the terms that are last in the situation, which I have a -2 and a 7. And -2 times 7 would be a -14. And of course, that's added in there. Okay. And now some of those addition signs, if you're going through, if you just write minus 10x here, and you don't necessarily write plus -10x, that's cool. That's not a big deal. But know that F plus O plus I plus L, we're adding those together. Now, when you do this, if you'll notice, the two terms in the middle, many times are going to be like terms. And so when that happens, you don't want to leave it like that. You want to actually combine those like terms. So my final answer would be 15x squared. 21x minus 10x would be plus 11x. And then plus a -14 would be minus 14. And so that's how you would go about multiplying the binomials 2x minus 2 and 5x plus 7. Note in this FOIL method, which can only be used to multiply two binomials. So if I have a monomial times a binomial, can't use FOIL. If I have a binomial times a trinomial, can't use FOIL. If I have a trinomial times a trinomial, no, doesn't work. The only thing we can use FOIL on is a binomial, okay? When multiplying two polynomials, be sure to multiply each term of one polynomial by each term of the other. Now, the last problem we did was 3x minus 2 times 5x plus 7. Okay, I'm going to do that again. 3x, you know what, I'll just do another one. It doesn't really matter. If I had, say, a 2x plus 4 times x minus 11. I could FOIL that. I'm going to show you real quick a method that always works. I don't care how many terms are in each of the ones that we're multiplying together. What I can do is take either polynomial, and it doesn't matter which one, and we're going to make this, we're going to make a 2 by 2 box because this is a 2 terms times 2 terms. So because I have 2 terms times 2 terms, I'm going to draw a 2 by 2 box big enough that I can write inside this box. And then I'm going to put one of the binomials on top, and I'll put the other binomial on the left side. So, and it doesn't matter which one you put where. So I'll put 2x here, and I'll put 4 here, so that's across the top, and I'll take the x and the -11 on the side. And again, this will work for any size polynomial. So if you're multiplying a 3 by 3, this is really a great way to get yourself organized. What we're going to do now is just fill in a multiplication table. So in this very first box here, I have a 2x and an x. Well, 2x times x is 2x squared. In my top right box, I have 4 times x, which is 4x. The bottom left box is -11 times 2x, which is -22x. And then the bottom right box will be -11 times 4, which is -44. So by doing the box, I've guaranteed that I have multiplied every single monomial by the respective monomial that needs to be multiplied by. Now, as I look at this, I combine my terms. Many times when you're doing this, you're going to see that your like terms are going to be on the diagonals. So I have a 2x squared. And then on this diagonal, I have a 4x minus 22x. Well, 4 minus 22 is negative 18, so it's negative 18x. And then there's our minus 44. And that's how you go about multiplying two binomials together using what's called a box method. And again, this is working on a monomial times a binomial. It would be a binomial times a trinomial times a trinomial. It doesn't matter. It's going to work all the time. So I'm going to look at a few problems here. Actually, at this time, if you would, stop watching the video, open it up, and look at these practice problems and work them yourself and see how you do. And then once you're done working the problems, come back and look at me solving them for you. The first problem, I have a monomial times a trinomial. So all I'm going to do is distribute this 3x. So 3x times x squared is 3x to the third power. 3x times negative 5x would be negative 15x squared. And of course, 3x times 1 would be plus 3x. And so that's all we have to do to number 1. Number 2, we're going to multiply again. We have another monomial times a binomial. So again, I will simply distribute the negative 2y. Negative 2y times a positive 4y. Negative 2 times 4 is negative 8. Y times y squared is y cubed. Negative 2y times negative 5. Negative 2 times negative 5 is positive 10. And of course, that y is just going along for the ride. Number 3, perform the operation and write the results in standard form. So on number 3, I have a binomial times a monomial. So even though it's kind of written this way, I can still distribute from the right side. So what I'm going to do here is distribute negative 5t times 5. Negative 5 times 5 is negative 25. And there's a t going along for the ride. And negative 5t times negative 1.5t squared. Negative times negative is a positive. 1.5 times 5 is 7.5. And t squared times t is t cubed. Now, if you see a problem like this on your homework and you leave the answer like that, you're going to be wrong. And here's why. If you'll notice, it tells us to write the answer in standard form. So remember, when you see standard form, that means decreasing powers. Well, the way I've written my answer right now, I've got 25t, negative 25t, that's to the first power, and then 7.5t cubed, that's to the third power. That's definitely not descending power, it's descending orders. So what I'm going to do is just rearrange it. The 7.5t cubed is positive, so I'll keep the positive sign, but I'm not going to write positive. That is 7.5t cubed, and this is a negative 25t, so minus 25t. And that would be how you write that answer in standard form. So don't miss a problem on homework or a test or something like that because you did not write the answer in standard form. Folks, just get in the habit of doing that. Make it a habit to write answers in descending power, even when they don't ask. It just makes life so much easier. All righty. Okay. I went back to make sure we did everything. Okay. Number 4, it says multiply the polynomials. Number 4 is a binomial times a binomial. So a reminder that because it's the binomial times the binomial, FOIL is a great method of doing it. If you prefer the box, you can do that. But I'm going to save the box for number 5. I'm going to go ahead and work number 4 by using the FOIL process. And so here we go with FOIL. First times first. We're talking about, let me back that up, give myself some space. First times first, we have 2x times 5x. Those are the first two terms in each of those binomials. Well, 2 times 5 is 10. X times x is x squared. Plus outside times outside. Outside times outside would be the terms that are furthest away from each other. That is 2x and 1. Well, 2x times 1 is 2x plus inside times inside. We're talking about the terms on the inside. They're the ones closest to each other. We have a -6 and a 5x. -6 times 5 is -30. And there's an x. And finally, we have L, last times last. Last times last, -6 times 1 is -6. And again, typically when you're doing a problem involving a binomial times a binomial, your middle two terms, if you're using FOIL, are probably going to be like terms, so make sure you combine those. So my final answer in standard form, 10x squared minus 28x minus 6. And then the next problem. I don't have a whole lot of space on number 5, so I'm going to do number 5 down here a little bit. So on number 5, I have a trinomial times a trinomial. So what I'm going to do here is I'm actually going to write a 3 by 3 box. So we have 3 by 3 box. And this next part, again, it doesn't matter if you put the first term on the left or the first term on the top. It doesn't matter. But make sure you're writing these on the left and on the top. I'll go ahead and write the x squared minus x minus 4 along the top. X squared minus x minus 4. And on the left side, I'll put x squared, 2x, which is positive, and 3. I don't write the pluses if they're positive. I just know they're positive. I'm now going to fill in my multiplication table. X squared times x squared is x to the 4th. X squared times a negative x, a positive times a negative is a negative. X squared times x is x cubed. X squared times -4 would give me -4x squared. Next row, the 2x. 2x times x squared is 2x cubed. 2x times -x would be -2x squared. 2x times -4 is -8x. And finally, the 3. 3 times x squared is 3x squared. 3 times -x is -3x. And 3 times -4 will be -12. So this has ensured that I've multiplied everything together. And real quick, I want to point out that what I did here, since I worked across from left to right, is I was actually working with that second trinomial. I took the x squared and distributed it to the first trinomial. Then I took the 2x and distributed it. And then I took the 3 and distributed it. Again, the box is just a format to make sure you multiply everything like you're supposed to. Okay. As I pointed out before, if you notice, the like terms are probably on diagonals, and they are. My highest degree term is x to the 4th. Let me back this up. I'm going to go ahead and put the answer up under number 5. That way I have some space to work on number 6. Okay. All right. So we have x to the 4th. And then along this diagonal, I have 2x cubed minus x cubed. Well, 2 minus 1 is 1. So I have plus x cubed. Along this diagonal is all my x squares. I have 3 minus 2, that's 1. Minus 4, that's -3x squared. And then I have my x terms. I have a -8 and a -3x. That gives me -11x. And finally, my constant is -12. So we took that trinomial times a trinomial, and our answer was in fact a 5th degree term. Okay, and number 6, we have 2x plus 3 and 2x minus 3. I'm going to go ahead and FOIL this again, but I want you to notice something here. Notice the relationship between 2x plus 3 and 2x minus 3. They're the same, except for one's plus 3 and one's minus 3. So when you see that happen, something weird is going to happen. So let me FOIL it for you and show you what happens. So I'm going to write out FOIL here. And I know I'm going to be adding all these things together. Write that down. Okay, so here we go. First times first. 2x times 2x. 2x times 2x is 4x squared. Outside times outside. 2x times negative 3. 2x times negative 3 is negative 6x. Inside times inside. That would be positive 3 times 2x. Positive 3 times 2x is 6x. And then finally we have last times last. 3 times negative 3. 3 times negative 3 is negative 9. Notice those middle two terms. Notice I have a negative 6x and a positive 6x. Negative 6x plus 6x is simply 0. So when I combine like terms, those guys are gone. So my final answer is simply 4x squared minus 9. So 2x plus 3 and 2x minus 3, that's a little special property that looks like this. Anytime you have a plus b times a minus b, it's going to multiply into a squared minus b squared. And we're going to talk about more of that in this course, but I just wanted to give you a little heads up. Number 7, it says multiply the polynomials 2x minus 5 squared. Folks, what you have there is 2x minus 5 times 2x minus 5. This is another special property, and we'll talk about it later as well. But I honestly have never worked it using that property. If I see 2x minus 5 and 2x minus times 2x minus 5 or 2x minus 5 squared as it's written, I'm probably going to go ahead and FOIL it. Okay, so I'm going to slowly start changing the way I do things. I'm not going to write out the word FOIL anymore. I'll talk about it, but I'm not going to write it down. So as we go through here, we have first times first. First times first, 2x times 2x, that is 4x squared. Outside times outside, the two far ones, outside times outside would be 2x times negative 5. 2x times negative 5 is negative 10x. Inside times inside. Inside times inside is negative 5 times 2x. Negative 5 times 2x, oh, look at there, another minus 10x. And then last times last. Negative 5 times negative 5. Of course, that would be positive 25. We combine our like terms. Again, normally when you FOIL it, it's going to be the ones in the middle. If you did this one with the box, it's going to be the ones on a diagonal. We get 4x squared minus 20x plus 25. And number 8, we have x minus 3 cubed. Well, folks, that means x minus 3 times x minus 3 times x minus 3. What we want to do here is just work it a part at a time. So let's work x minus 3, x minus 3. And then we'll worry about the last x minus 3 in a moment. By FOILing that, first times first, x times x is x squared. Outside times outside is negative 3x. Inside times inside is also negative 3x. Outside times outside, negative 3x. Inside times inside, negative 3x. Negative 3x, negative 3x, that's negative 6x. Last times last is plus 9. I now have a trinomial. And I'm going to have to multiply the result I got from x minus 3 times x minus 3. I'm going to take that result and multiply it by another x minus 3. So what I'm going to do here is I'm going to go ahead and build a box under this trinomial. And since it's a binomial times a trinomial, it's going to be a 2 by 3 box. So I've already got x squared above this column, negative 6x here, and 9 here. All I need to do is take my x and minus 3 and put them on the side. And I'll now multiply and fill in this multiplication table. X times x squared is x cubed. X times negative 6x is negative 6x squared. X times 9 is 9x. I'll now multiply the negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 6x will be positive 18x. And negative 3 times 9 is negative 27. Now that I've done on multiplying, I can combine my terms. To write this in standard form, we'll start with the highest degree. The highest degree is 3. I only have one term with an exponent of 3, so that'll be my highest term, x cubed. I have two terms that are x squared. I have a minus 6x squared and a minus 3x squared. Minus 6 minus 3, that's minus 9x squared. My x to the first term, I have a 9x and an 18x. Well, 9x and 18 more x's gives me plus 27x. And finally, my last term is my constant, or minus 27. And that completes that problem. And if I'm not mistaken, that concludes section P3. So I'm going to stop the recording now, and the next recording I'll do will be for the next section. Guys, if you have any questions about anything that we've done today, please contact me. Refer to the syllabus, refer to the first video that I shared with you so that you can contact me if you have any questions. What I want is I want all of y'all to be successful. Y'all have a great day now.